This is lesson 4, the sine law, part 1. Thanks for watching these videos. I'm sorry, I know they're not perfect. I know there's probably some sound issues and other issues. Sorry, it takes a long time to make these, and they're not even that great a quality. So I'm kind of learning as I go. With so many videos to record in so many classes, there's going to be some mistakes. If you find a mistake that I've made or a math error, don't be afraid to send me a message, or even just reply to the assignment, or just post in Edsby that you think it's wrong, and other people can reply and we can fix the error. As I said, I just got to keep kind of going. I'll try to be really careful and make no errors, but if it happens, it happens, and I'm not embarrassed. Feel free to point it out. Okay, so today we're going to start talking about the sine law that you learned in grade 10. So basically all this trigonometry we're doing is really review of grade 10 in this unit. So you've done the sine law before, so let's talk about it. The sine law is great because you can use it to solve non-right angle triangles, right? We need SOHCAHTOA for right angles, but here's the thing. With sine law, you can even solve right angle triangles with it. So sine law is kind of the ultimate, easiest, fastest way to solve pretty much any triangle, right angle or non-right angle. So you can use this for any of them, except for a couple scenarios, and we're going to talk about that first. Okay, so we're going to go through all the different scenarios and where you can use sine law and where you can't. Okay, so first, if you have a triangle and you're given, I'm just going to kind of put a dot what you're given. Let's say you're given a question and you're given this angle, and this angle. You're given all three angles, but you're not given any of the side lengths. So we would call that an angle, angle, angle triangle, three angles. Okay, so what do you do here? How do you solve it? Well, here's the thing. You can and you can't solve it. The idea is there are actually infinite possible solutions here, infinite possible triangles, okay? Or solutions or triangles. Now, why is that? Because I could have a tiny triangle with those angles. I could have a giant one with those angles. So you could come up with anything. You could basically make the side length. You could pick one of the sides to be anything you want, and then you could use sine law to solve for the other side lengths. So here's the thing. We're not going to be giving you anything like that. Okay, that's more of a theoretical question or a computer science question where maybe we have a certain triangle, we're zooming in and out on it. So don't worry about that one. You're not going to encounter that, but we should be aware of it. Okay, so there's our first scenario. So that one we don't have to worry about. The next two we're going to talk about are the two you can't use sine law for, that you absolutely have to use the cosine law for, and we're going to talk about that in a future lesson, in lesson 6. Okay, so what do they look like? If you are given the three sides, so if you're given this side, and this side, given the three sides, a side, side, side triangle, you won't be able to use sine law. Now the thing is, you don't have to memorize all these scenarios. I'll show you as we go that basically when I solve these, I always just start trying to use sine law. And when you get to a place where it just doesn't work, then you realize you have to use cosine law. So don't feel like you have to memorize every single one of these scenarios. All right, the next one is if you have a side angle side. So that means you have a side here, you're given those two, and you're given the angle between them. So if you try to use the sine law, it won't work. You'll realize you don't have enough information for it to work. So these ones here, these two scenarios are where you have to use the cosine law. So we won't have any in our homework for this or in our lesson today. We'll talk about those in lesson 6. Okay, so we don't have to worry about it. Like again, I don't always have, I mean, I've done it enough. Obviously, I have them memorized, but even when I was your age, I didn't memorize them all. I would just start with sine law. If it doesn't work, okay, I'm going to cosine law. All right, the final three are the ones that we have to use sine law for. All right, and then we'll talk about what the sine law is. Okay, so angle, angle, side. What does that mean? It means you're given one angle, you're given another angle, and you're given the side that's not between them. So that's what we call an angle, angle, side. Now you could switch this around and go side, angle, angle if you want. It doesn't really matter, right? But the idea is you have two angles and the side not between them. That's one over here when you have side, angle, side, right? That's different. Okay, so there's one where we have to use sine law. So let me just get rid of this. So we'll just call it angle, angle, side for now. All right, the next one where you can use sine law is if you have an angle, side, angle triangle. That means you're given an angle, you're given the side, and you're given the angle on the other side of it. So you have a side with two angles next to it. So that you can use sine law for. And the final one, and I'm not trying to make a joke here, is the angle, side, side. This is the only one that you have to watch out for, okay? So this one's important. And luckily, it has the easy to remember name. And again, I'm not trying to be inappropriate or make a joke, but it is kind of convenient that this is the one that you have to watch out for. All right, so this is when you have an angle, and then you are given two sides like this, okay? Now, there's only two scenarios where you are given one angle, right? There's this one over here on the cosine law, and there's this one here, right? So this is the one we're going to talk a lot about in lesson 5. So I'm going to try and simplify it as much as I can. I hope I don't over-explain it, but the idea is there isn't much to memorize. All you have to look out for is this one triangle and be on the lookout for it. So you should be suspicious if you're only given one angle. Anytime you have a trigonometry question and you're only given one angle, it's either the one that causes us trouble or it's the cosine law one. And the thing is, if you can't use the sine law, it has to be the cosine law, and that's the one that, and then or else it's this one that gives us trouble. So this guy we call the ambiguous case. Now, why is that? Well, we're going to talk about this a lot in lesson 5. I'm going to dedicate a whole lesson to this, but I'm just going to briefly mention it. We won't do any of them in lesson 4, and then lesson 5 will be all about this one. So just be on the lookout for this. Now, why is it called the ambiguous case? Because, as we'll show you in lesson 5, this one can have, given the information you're given, it can have 0, 1, or 2 possible triangles. Now, it might seem weird, but again, we'll explain that. We'll dedicate all of lesson 5 to that, okay? So today, we're just going to focus on sine law, and everything we solve is basically going to be one of these or one of these. And then tomorrow, it's all about, or the next lesson, it's all about this one. And then our final lesson this week, we'll be talking about the cosine law ones, okay? So this is today's lesson, the angle, angle side, and angle side angle. Now again, don't panic about memorizing it. I know I'm repeating myself. I'm sorry. I don't have time to go back and re-edit everything to make it sound beautiful. But the only one you need to keep in mind and always be looking for in math and when you're solving triangles is, was I only given one angle? And is it the angle side side, okay? Now if it's side angle side like this guy, we have nothing to fear because there's no way we could solve it with sine law anyways. We would use cosine law, so it doesn't matter. So if I can use sine law and I'm only given one angle, that's the ambiguous case. So that's tomorrow. All right, so for now, let's just talk about the sine law, what it is, remind you of it from grade 10. And yeah, I'm going to pause and go to the next slide here. Okay, so the law of sines, or the sine law, let's just label our triangle here. We can call it whatever we want. I'm just going to label this A, B, C. So those are our vertices, our corners, right? So, you know, angle A, angle B, angle C. And then we use capitals usually for vertices, so for the corners. And we use lowercase for the sides. Now the sides are labeled with the same letter, but lowercase across from it. So side A would be across from angle A here. Side B would be across from angle B here. And side C, which obviously it's hard to tell sometimes, lowercase and uppercase C, would be across from there. All right, so what's the sine law say? It says this. It says that if you take the sine of any angle and divide it by the side across from it, it is proportional to the sine of any other angle and the side across from it. So I could say sine A divided by side A equals sine B divided by side B. And generally what happens in these scenarios, you are going to be given 3 pieces of information and you solve for the third. So let's say I have side A, side B, and angle B. There's the 3 things I have, and then I could solve for that. All right, so let me just clear this out here. Now we can extend this a little bit further and say, well, what about side C and angle C? It's the same thing. So you could also say, okay, fine, sine of C equals the side C across from it. And you would basically just pick 2 of these, set them equal to each other, and solve. Now the way I set it up here is a lot better if you're solving for the angle, because the capital A is for, and capital B and capital C are for angles. So you can set it up that way. Now this is proportional, so we can just flip it. So if you're solving for a side and you prefer, you could actually set it up like this, upside down, and you'll still get the same answer. So you could flip it like this and put the sides, the lengths, right, on top, and put the angles on the bottom, like this. Now you're not going to work with all 3 of these fractions at once. You just work with 2 of them. And it can be whatever, because like let's say we have a triangle. It doesn't matter the letters, right? Let's say this is X, and this is Y, and this is W, and here's little x, and here's little w and little y. Right, I could go, all right, fine, sine of x divided by side x equals, let's use w, sine of w over side w. So just keep this pattern in mind. The idea of taking sine of an angle divided by the side across from it equals sine of another angle, any other angle in the triangle, divided by the side across from it. So let's do a couple examples and show how this works. Again, it's something you learn in grade 10, but it's really important for those of you who are continuing math. Like all of this stuff is, I'm trying to keep it to the bare bones, main essential things that you have to be really good at. I'm going to try to get rid of all the extra, just keep it to the main lesson. Super, super important stuff for moving into grade 12. So being able to solve triangles using law of sines is one of those topics. Okay, let's do example 1 here. We're given a triangle that has angle A, angle C, and side A. And we need to solve the triangle. And what it means by solve is find the other missing piece of information, which means angle B, side B, and side C. So let's solve for all that stuff. Now, I can't tell you how many times I tell people this and they don't do it, and I don't even get how you'd solve most of this without drawing a triangle. Draw a picture. It's going to help you. It's the first thing you should do. I mean, I'm 40 years old and I've been doing math since I was, as long as, your age, and I still draw a triangle, right? I want to make perfect sense of what I'm doing. So I'm just going to go A, B, C. It doesn't really matter where we put them. All right, and that means this is side A, this is side B, and this is side C. All right, so I'm going to label what I know. I know angle A is 35 degrees. I know side A is 44 meters. And I know angle C is 62 degrees. Now, I don't have that ambiguous case I was talking about because that only occurs when I'm given one angle. I'm not given one angle, so I'm safe. I don't need to worry about anything weird or special. What we have here is an angle, angle, side triangle. Angle, angle, side. Why? Well, go in order. We have an angle here, we have an angle here, and we have a side that's not between them. See, we don't have this side. If we had this side, it would be an angle, side angle triangle, but we don't. So this is an angle, angle, side triangle. All right, so let's start solving it. So how I'm going to do that is I'm going to set up my sine law. Now I'm going to highlight the important piece of information here we have when we're setting up sine law. Look, we have angle A and we have the side across from it. So that's going to be one of our fractions, sine of 35 over 44. We have angle C, but we don't have the side across from it. So that's going to be the first thing we solve for. So let me show you what I mean. Here we go. Let me just set up using the letters we have in our triangle. Sine A over side A, and let's use C. Sine C, which is angle C, divided by side C. And let's fill in everything we know. Well, I know angle A, and I know side A, which is 44 meters. I know angle C, which is 62 degrees, but I don't know side C. All right, so we have 3 pieces of information. We're looking for the 4th. Now in this scenario, it might have been better to flip it and set it up the other way, because look, the thing I'm solving for is on the bottom there. Or you can just do cross product like this. So let's look at, we could do it this way. I could multiply across, just multiply across doing cross product, right? And go, all right, C times sine of 35 degrees. Maybe this is the easiest way too. Or you could just flip both fractions and we'll get the same thing. And then I'm going to divide both sides by this sine of 35 degrees here. So C equals 44 times sine of 62 degrees divided by sine of 35 degrees. Now, like I said, you could also take this here. I'll just do a little kind of side here. You could also take this and just flip everything and make it 44 over sine of 35 equals C over sine of 62. And I could have just started with it upside down like that and then just multiply across, and I'd still get the exact same fraction that I have right here. Okay, so now it's just calculator time. So what you want to do is make sure your calculator is on degrees, right? Everything we do in this unit, let's make sure it's on degrees. No radians in this unit, okay? We're just doing everything with angles. We're using degrees. So you're going to go, well, what's sine of 62? Times it by 44 and divided by sine of 35. Now, just to save time, so you're not watching me just push buttons, I'm just going to write down the answer here. I'm going to round everything to 1 decimal to keep it really simple. I got 67.7 meters. All right. So that's what we get. So try it on your calculator and make sure you can get the same answer. That's the first thing to do. Can you get the same answer punching it in? Okay, then you know how to hit the buttons in the right order. That's really important. Basic, but important. All right, so there's our side. Let's fill that in there. 67.7 meters. All right, now we're going to solve for the other side. Let's just set up our fraction again. Now, you know what? I'm going to set it up the other way. I'm going to learn my lesson. I'm going to put the b on top. So we're solving, right? We need angle b and, oh, you know what? Silly me. We can find angle b really easy. Got to find that first. Angle b. Well, how are we going to get angle b? Well, every triangle has 180 degrees in it, right? So 180. We already know two of the angles, so let's find the third angle by subtracting. So we'll do that first. All right, so 180 minus 35 minus 62 is 83 degrees. Okay, so we got angle B, 83 degrees. I could have done that right at the start also, obviously. Okay, so the final thing to find now is solving for side B. And let's just set up the sine law a third time here to solve for that. So I'm going to start with side B on top because that's what I'm looking for. And really, that's the cleverest, quickest way of doing it. What are you looking for? Make that the first thing you set up. So I'm going to put B first. Over sine B equals on the other side. Now, here's where we got to choose. Should I use C or should I use the A's? Well, look at the A's were given to us here. We are 100% sure on those numbers, like 100% sure. What if I messed this C up? What if I got that wrong? And I had to round it too. If I use these in this calculation down here and I messed it up before and I rounded, right, I'm going to get a less accurate or an inaccurate answer. So instead, always try to use numbers you're given. Now, you can't always do that, but let's try and use the ones we're given. So we're going to use the A's here. All right, so we are 100% sure that side A is 44 meters, and we're 100% sure that angle A is 35 degrees. Oops. And my B here, I wrote B, but I should have, well, I guess I'm subbing in already. Sorry. Let me write the formula out first. My bad. Sorry, guys. I know I'm doing 100 of these a day, and I'm jumping all around. All right, side B equals B. We're going to use A, so side A over sine A. There we go. Okay, so we know angle B is, what was it? Let me write in my diagram here. 83 degrees. All right. And we know side A is 44, and we know angle A is 35. All right, so I'm running out of room here. But we're going to multiply across, just cross product. Let me bring this up here. So B is equal to 44 times sine of 83 degrees divided by sine of 35 degrees. So try punching that in your calculator. Make sure you can get the answer the same as me. And for B, I got approximately 76.1 meters. All right, so we've solved that triangle. We found all the missing information. So when you're told to solve a triangle, it means find all the other missing information. And when you submit any final answers to me, basically just make a little chart like this or make a list. Write out everything like this, right? Write out all your stuff basically like that. You can make a box like I did, or just list them, you know, angle A equals, angle B equals, angle C equals. That's basically your final answer. Write it all out, okay? All right, let's do one more here, and then we'll see what else we got to do. Okay, so we got another triangle, and I'm going to draw it up here this time. And again, I don't know, these are not drawn accurately. I'm just drawing a triangle, right? This is not drawn accurately to what's going on. Let's label it. We got D, E, and F. So angle D, angle E, and angle F. And side D would be over here, side E would be over here, and side F would be over here. All right, so they gave us angle D, which is 50 degrees. They gave us angle E, which is 82 degrees. So we're given two angles, so we know it's not that weird ambiguous case. Nothing to worry about. Just solve it like normal. And they gave me side F over here, which is 79 kilometers. All right, so what kind of triangle do we have? Well, let's think here. We got an angle, a side in between it, and another angle. So we call this an angle, side, angle triangle, right? So angle, side, angle. This guy's just a regular old sine law one. And again, even when I was your age, I didn't memorize which I had to use. All I watched out for was that angle, side, side triangle. It's the only one I was checking for. If I got a triangle and I went to use sine law and it didn't work, then I knew it had to be cosine law. So it's just more of a process of deduction. Instead of memorizing every scenario, don't waste your time. Just watch out for the angle, side, side one, which we'll talk about in the next lesson. And if sine law doesn't work, go to cosine law, which we'll talk about in lesson 6. All right, so let's check this out here. Now, the first thing I can do, and I should have done that in my last triangle, is why don't we find the missing third angle here? All right, so to do that, pretty easy. Again, we have 3 angles, right? And 3 angles on a triangle always add to 180. So to find the missing third angle, angle F, just take 180 and subtract the 2 angles that you're given. All right, so when I do that, I end up with 48 degrees. All right, so let me write this in my little table there, write that over here. All right, cool. Now, I'm very confident with that number. No rounding or anything special, so I'm okay using that. All right, so let's start solving for some missing information. So we can solve for D, side D or side E. It really doesn't matter at this point. Those are the two things we're missing. So I'm just going to start by solving for side D here. Okay, so I'm going to set up my formula. D, side D over sine of D. So I'm going to put the side on top because that's what I'm looking for. And let's use the only one that we have both pieces of information. I can't use this because I don't have both. So to use sine law, you have to have one angle and one side across from it. Well, that would be F right there. So we can definitely use that. So let's use angle F and side F. You have to use sine law, an angle and the side across from it to work. Okay, so let's use side F divided by sine of angle F. All right, so let's sub in everything we know. D, we don't know. Angle D, we do know, is 50 degrees. Side F is 79 kilometers, and angle F is 48 degrees. Okay, so it's a proportion. It's like a proportion you did in elementary school, like you did in grade 9. When you have two fractions equal to each other, we call that a proportion. And to solve a proportion, you have three pieces of information, and you have to solve for the fourth. And that's exactly what we have here. So let's just use cross product. In other words, multiply both sides by sine of 50. We get D equals 79 times sine of 50 degrees divided by sine of 48 degrees. And do that in your calculator. Check if you're getting the same answer as me. I am getting 81.4 kilometers is what I got for a side D, approximately, rounding everything to one decimal place. So I'm going to write that in up here. Just clean that up. 81.4 kilometers. Okay, I'm going to write that on my diagram this time also. I should have done that on the last one. All right, now to solve for the other missing side, we got to solve for E. Again, I am not going to use this in my calculation because what if I mess that up? What if I goofed it up? I also had to round it so it's less accurate. So I instead am just going to go back and use this. So I'm going to use these two, right? Because we're sure this is right. We're sure this is definitely right. We're sure this is right. So those are three numbers we're really confident with. So let's use them instead. Now, I'm not saying you couldn't use angle D and side D, but if you want to just always play it safe, then use the ones you're sure about. All right, so let's go side E divided by angle E is equal to side F again over sine of F. All right, so we don't know side E. We do know its angle is 82 degrees. We know side F is 79, and we are very certain, even though we had to do the calculation, that angle F is 48 degrees. All right, so same thing. Let's do cross product. Just multiply both sides by sine of 82. 79 times sine of 82 divided by sine of 48. Punch it on your calculator. You know, make sure it's on degrees, not radians. And I get approximately 105.3 kilometers. There you go, sine law. Now again, like I said earlier, you can use sine law to solve even regular old right angle triangles. Some people use them to solve everything. They don't use SOHCAHTOA at all. Now you still got to know the patterns to SOHCAHTOA because it's important for some other trigonometry stuff that specifically is only about right angle triangles. It's going to come up. But if all you really care about is solving, sine law might be your way to go for everything other than the two scenarios where we got to use cosine law. All right, we're going to check out one more topic here today. I lied. We're going to talk about two more topics. Here's an example word problem, and then we got to do one more topic. All right, I'll try and move through this a little quicker. This is a classic test question, hint, hint, wink, wink, using sine law. Okay, so we got a satellite above the Earth somewhere. Long story short, this is going to draw a triangle, so I'm just going to draw the triangle, and then we'll talk more about it here. Okay, so I got my triangle drawn. There it is. We got a satellite. It says the satellite's orbiting the Earth, and it's up in the sky, so I'm just going to write satellite here. I'll just write sat for satellite. And it looks down at two places. It looks down at Los Angeles, and it looks down at Phoenix. All right, I'll just write that for those. Okay, and Los Angeles and Phoenix are 340 miles apart. 340 miles apart. At an instant when the satellite is between those two stations, its angle of elevation is simultaneously to be 68 from Phoenix and 75 from Los Angeles. So the angle of elevation means if you're in LA and you're looking up, it says looking up from LA, you look at that satellite, it's 75 degrees. If you're in Phoenix looking up at that satellite, you are looking at an angle of 60 degrees. All right, so this question wants us to find how far is the satellite from Los Angeles. So I'm just going to put an X right here because this is what it wants, this length from there to there. Okay, so let's start by setting up our sine law here. So I'm going to start with X because that's what I'm looking for. And I'm going to set it over sine of the angle that's across from. So sine of 60 degrees. Now for this to work, we need another side and angle that are across from each other. Now we have this side here, 340, but we need to find the angle across from it. And again, that's going to be really easy because if you have two angles in a triangle, you can find the third. So the angle, I'm just going to write angle at the satellite, is equal to 180 minus 75 degrees minus 60 degrees, and we get 45 degrees. Sorry, the 4s keep getting attached with this pen and making them look like 9s. There we go. Okay, so sine of 45 degrees. Okay, so we got a proportion again. We can just multiply both sides by sine of 60, which basically just does the cross product, which just means it multiplies across like that. 340 times sine of 60 divided by sine of 45. Put that all into our calculator. And just to save time, I already got it calculated, and I got the distance as approximately 416.4 miles. There you go. Just a quick sine law question. All right, we got to do one more important topic, sorry, and then that'll be the end of today's lesson. This is a pretty long one. The next one's a little bit long, and then the last one's pretty short. Okay, our final topic today is finding the height and area of a triangle. So let's say we have a triangle like this and we want to find the area. To find the area, we need the height. So I'm going to draw the height in here with a straight line the best I can. There we go. All right, now to find the height, you basically need one of the angles in the corner. So let's just say we have angle A, and I'll call that theta. Now obviously you could work over here with B and do the same thing. We'll just work with A for now because it's the same thing no matter what. Now let's go back to, remember, let me label our sides because we're going to use a little bit of SOHCAHTOA here to kind of come up with the formula. So let's see, if this is our angle, this would be the adjacent, this side here. Just talking about from here to here, just looking at this right angle triangle I've drawn. This would be the opposite, which is our height, right? And this side would be our hypotenuse, the B side. All right, so we're going to make a quick formula to find the height of a triangle. So sine of an angle is equal to opposite over hypotenuse. Now, again, you could do the same thing with this triangle over here, right? We just switch it around. We'd be working with this angle, and this would be the hypotenuse, and this would be the adjacent. So you can work it either way. You can rotate your triangle around, whatever you have to do to figure this out. So you basically draw on a right angle triangle somewhere where you have this angle and you have this hypotenuse. Now, what if I want to, since the opposite here is my height, since that is my height, I want to isolate that because that's what I'm solving for. So all I got to do is multiply both sides by the hypotenuse. So just quick cross product, let's multiply that. So in other words, the hypotenuse, I'll just write hype in brackets, times sine of an angle is equal to the opposite. So that's our formula. Let me just flip it around here. Just flip things around. So I'm going to, instead of calling it opposite, I'm going to call it height. So height is equal to the hypotenuse of your triangle there that's touching the angle times sine of that angle. Now, this is one, to be honest with you, like I even forget this formula. Now, you got it right here in front of you, but I even forget it. But anytime I forget it, I don't stress, I don't memorize it or go look it up. I just draw the right angle triangle like I drew here, and I just use my SOHCAHTOA to figure out what the height is. So basically, you could even forget this formula and just use SOHCAHTOA and say, all right, how am I going to solve for that? Okay. All right, so let's do two examples where we're finding the area and height of a triangle. I'll do two more real quick. Okay, so we're going to look at two possible triangles. Now, here's the deal. Neither of them are drawn for us, but let me talk about it. The angle I'm given here is an acute angle, right? It's less than 90 degrees. So we got an acute angle. So I'm going to look at one where we're given an acute angle versus given an obtuse angle. The acute one's easier because it's just the shape, I think we're just more familiar with where everything goes. So let me just draw an acute angle triangle here. In other words, I don't want my angle to be bigger than 180. Oops, move that over. Okay, I'm back here. There we go, I just fixed the triangle up. Okay, so we got an acute triangle. Let's just put A here, and I'm gonna put B here and C here. Now, if I did it the other way, I just have to rotate my page a little bit. Why am I doing that? Okay, so this is 70 degrees here. Side B is 60 meters over here. There's side B. And side C we have is 124. We don't have side A, and we don't need side A for this problem. All right, so where's our height? Let's draw our height in. Now, again, if you drew it and things aren't the way you like, just rotate your paper, okay? So I need the height here. I want to find the height because I have this side here and I have this angle. That's what I need to make this work. Now, again, let's just say you don't remember that formula, right? You can just do SOHCAHTOA, right? You can just use the sine law. So I'll set it up first just using the sine law. Like, let's say, and there's our, we'll call this our H for height. All right, so if I'm solving for height, I could use sine, right? Sine of an angle is opposite over adjacent, right? Oh, sorry, opposite over hypotenuse. Silly. Oh boy, come on, Colty. Sorry, I'm like watching my kids outside wrestle with the dog while I'm trying to do this here. All right. Okay, so sine of 70 degrees equals, the opposite is the height. I'll just call it H for height. And this would be the hypotenuse over here, right? Right, this would be opposite. There you go. So it's 60. So there you go. So you don't even need that formula like I wrote above. I just wrote it because that's the formula you'll see in books. But really, it's not even something you can memorize. Like, I find a lot of stuff I solve as I got older, I stopped memorizing some of the formulas, and I just kind of started going back to what I know and applying it. So here I draw the line and I go, okay, there's a right angle triangle. I can just solve it that way instead of memorizing a billion formulas. You got to know some, but the less, the better, right? All right, so there's my height. Ta-da! Height is 60 times sine of 70. Now, I'm not going to even bother calculating that. It says find the area of the triangle. Okay, so I'm just going to leave it like that for now instead of getting a decimal. So area equals base times height, right? Base times height divided by 2. Okay, so let's just sub it all in. So the base of this thing is here. There's our base, 124, based on the way that we have this triangle laid out. So 124. Now, like I said, the only problem you'll run into is maybe you draw your triangle and things aren't where you want it. Just rotate the page and draw your height in at a different spot. Because like if we rotated, I could draw the height in here, right? Or I could draw the height in here, depending on which way it's facing. So sometimes you just got to take a second, flip it around and try it. I know I'm getting right to the first answer the first time, right? But even when I do something like brand new like this, I got to take a second and rotate my page, see where things go. All right, so the base is 124. The height, we just came up with that formula, 60 times sine of 70. All right, and then divide that by 2. So punch that all in your calculator. I'm going to save us some time. I got 3,495.7 approximately meters squared. There is the area of my triangle. That's it. Now I got to do one more. I want to do one where it's an obtuse angle because that's the one that really messes people up. And the problem is if you don't recognize that it's obtuse, if you don't think about that and you just draw the same triangle I drew in the first one here, it's not going to work and you're going to get all confused. All right, so let's do one more. All right, we're finally getting to the end of this long video. Sorry about the length. I don't love it either. I'm trying to cut everything down to as little as I can, but still getting the important stuff because it is important. Those of you that want to continue in academic math and go into fields, this isn't, it's not a joke. This is stuff you have to know. And, I know the situation's terrible, but if you don't do these questions, try them, watch these videos a couple times through, ask questions, in the end, it's your life. It's going to be on you what you do and don't do, okay? So get involved, try stuff out. I know it's kind of a crappy situation. All right, so we got our final one here, and this is an obtuse angle, right? That's bigger than 90. So my triangle has to have a bigger than 90 angle. So I'm going to just kind of draw one here. So in other words, I got a triangle that's kind of like this, right? We have to draw an angle that's bigger than 180. Okay. Or bigger than 90, sorry, not 180, silly. Okay, so we know this is, I'm going to make this is where that obtuse angle is. There's where that 120 degrees is, and that's angle Q. Now the other two, I'll put the R up here and I'll put the P down here. I think that'll work out the best. But again, sometimes if you draw it and it doesn't work, try switching things around, try redrawing your triangle. Again, when I do this stuff from scratch or when I was doing it your age, it takes a couple seconds sometimes. There's side Q, here's side R, which is 10 centimeters, and side P, which is 3 centimeters. You know, you gotta try again. Perseverance is very big in math, and it took me a long time to kind of get that. It took me to university to really figure out that I can't just try it once and then quit and say, well, that's too bad, the end, right? All right, I'm just gonna redraw this here a little bit because I want to draw something on the side here. All right, so where's our height? How tall is our triangle? Here's the secret to this one. The height is measured from here to here. So I'm gonna draw a right angle triangle in here. Right, this is our height. I'll just write H for height over here. Make that a little bigger. Capital H for height. Okay, that's my height right there. So in this case, the height is not inside. If you try and draw the height here, that's not how tall the triangle is. The height is right from the bottom to the top vertice there. Okay, so what we need to do is figure out that. So let's think of our sine law. Like, what do we have? This is our hypotenuse, right? This is our opposite. This is our adjacent. Well, I want to figure out the height. So I'm going to use sine law. Sine of an angle equals opposite over hypotenuse. And again, those of you who prefer to use the components of doing this, if you know what I'm talking about, go for it. I know a lot of people, there seems to be this negativity towards SOHCAHTOA, but it's just all it is a practical, quick way of just memorizing the pattern of the component math, which they're the exact same thing. In one way or the other, you're still memorizing something. So, but anyways, back to this. All right, so let's sub in what we know. We know this angle here, right? We have to find this angle right here. It's not 120. That's the other trick, right? Here, that is what we call a supplementary angle, right? So if this is 120 on this side, the other side, they have to add to make 180. So 180 minus 20, this side here has to be 60 degrees. So that's a 60 there. So I'm actually going to do sine of 60 equals the opposite, which we'll just use H for height, divided by the hypotenuse, which is that 3? Man, I can't even read my own writing. 3 centimeters. All right, so let's multiply both sides by 3, which is just a quick cross product. 3 times sine of 60 equals H, and that's our height. All right, so now let's find the area of this thing. So when we're doing the area, again, area equals, I'm just gonna write B times H, base times height divided by 2. All right, the base, this is the base from here to here. That's the 10. That's the base of my triangle. So 10 times the height. I don't need this part here. People start saying, well, what about this? This area here is not part of the triangle. We were just using that triangle on the outside to figure out the height. So base times height, the height is 3 times sine of 60, and then divide that by 2. So if I'm punching this in my calculator, I'm going sine of 60 times 3 times 10 divided by 2. Obviously, you can do some reducing if you prefer. And long story short, we get approximately 13.0 centimeters squared as our area. Okay, so that is the end of a very long lesson. Thanks for hanging in there. Again, if you have questions, I'm going to start setting up a way to ask questions, but feel free to ask them on Edsby. And I'm going to see what other teachers are doing to try and find a way to do homework and answer questions with you. But feel free to just post right on the board. The nice thing is if you post there, everyone can see the question and we can kind of answer it together. I know some of you might be embarrassed to do that, but to me, it's really the opposite. It's a place for discussion. And when you ask a question, it kind of gets the ball going and gets the discussion going. But if you want to send me a private message in Edsby too, that's cool too, whatever works. All right, so check out lesson 5, and thank you very much. And hang in there, guys. Talk to you soon.